Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I do data engineering and machine learning at Databricks. And I'm joined by my co host.
Ben Wilson. I work on quarterly plans at Databricks.
Today, we are not joined by a guest. We are joined by myself and Ben. And what we're going to talk about is a really formative experience for me. And we're going to walk through basically how Ben approached teaching me and sort of mentoring me through a very challenging project. And this project was building the Llama Index flavor for MLflow. So if you're not familiar, MLflow manages machine learning model lifecycles, so model versioning, experiment tracking. It has some fancy Gen AI stuff like tracing. And in MLflow, there are things called flavors, which are essentially wrappers around common projects. So scikit-learn, TensorFlow, Keras, PyTorch, you name it. And I just built the flavor for Llama Index with some help from another engineer on the MLflow team. And this project was a big learning experience because I wanted to learn basically how software is done, specifically at Databricks. And I'm not going to lie, it was hell. There were like some really challenging times. There were some very long Saturday nights. Well, maybe not so much Saturday nights, but there's some long Sunday nights, long Friday nights. And I ended up learning a ton, and we were just going to go through and sort of reflect on what things I found valuable in the learning process, and then also discuss Ben's approach to mentoring and teaching. And yeah, hopefully this will give some value. It'll give a little window into how the Databricks engineering culture works. It might not be the best fit for you or your organization, but at least it'll be a very honest look at how one organization does teach. So, Ben, over to you. What questions do you have?
Yeah, I mean, before we started recording, the question that came up, we were like, what are we going to talk about today? And I just asked, I was like, well, what did you learn doing this process? Because I mean, it just released this past Monday. If you're an MLflow user and you're really curious about Gen AI applications, it's super awesome. The library's like really slick. And what Michael and Yuki built is awesome. I remember bug bashing it about 3 weeks ago, or the first one was like a month ago, and then I did like 3 weeks ago bug bash. I was like, man, there's not a lot of issues with this at all. So like really having to dig in and really try to find something to give you feedback on. I was like, this just works. This is awesome. Um, but yeah, you said that you like wrote down a list of things that you learned. Let's go through the list, man.
Okay. So I have historically been a big journaler, and less so in the like recent year or two, but I still wanted to reflect on this experience because putting words onto paper really helps my brain stop thinking about it, and it also helps me conceptualize and sort of harden the learnings that I had. So uh, I think going through this list in one shot might be a bit verbose, but at a high level, I came in being able to write Python code. I was pretty okay at implementations. I would typically do one or two refactors for anything more than like 50 lines. Like I couldn't just bang it out and have it be flawless. Now I actually sort of can, which is cool. And the thing that I was really missing is the software engineering components. So, for instance, there's a module in Python called inspect. It allows you to look at an import path, a signature, that type of thing. I learned about serialization and deserialization. Like, what does that mean when you take an in-memory thing and write it to a something on disk? So, like, convert an object to JSON or object to a pickle file. I learned about Git development. Like, PRs definitely was comfortable with that, but what's a feature branch? How do you stack PRs? How do you review? What's the tone? Um, I arguably the most valuable thing I learned was test coverage intuition. Like, what do you think needs to be added to your test suite so that you are guarding against edge cases that you might not be super sure of? But likewise, how do you do that without literally testing all of Python and all of Llama Index? And then more importantly, how do you like augment things that are external dependencies? So if you have something that does an API call to an external service, how do you mock that? How do you patch that? On the technical, all of PyTest, so patching, mock, fixture, conf test, parameterization. I learned about Spark UDFs. That was a weird one. Uh, and I guess those are the core like base Python things and software things.
Yeah, and that's the interesting thing to kind of bring up about the difference between, because you currently work in a role, and I used to work in a role, and at previous companies I was doing this stuff where you're using these libraries to solve some business problem. Like, hey, I need to move data from this place to this place and do all this crazy stuff to it, join all these tables, and then I'm going to take something with that data and build a model out of it, and then I'm going to do my validation and try to tune it. And when you're cranking that stuff out, even if you're adopting best engineering practices with that development workflow, at the end of the day, the only thing that you really care about is like the results.
Yeah.
So a lot of times you're doing an integration test to say like, hey, before we release this to production, let's make sure that the predictions look legit, that there's not crazy stuff happening. So the testing mentality for that is way different than if you're building framework code, like, pure software engineering code. And when you're doing applied development, you're not concerned so much about doing stuff like type validation, and you don't have to use those parts of the language that much. Like the frameworks that you're using handle that for you, as they should. So I'm curious to hear your perspective on what was it like learning those things? Was it an epiphany of like, I didn't know that this was part of the core language, or I didn't know that like somebody had thought this up to build all of this? Or was it more like, I know what I need to do to like solve this problem, so I'm going to go and like write my own implementation of it, and then later on, like retroactively, you find out by talking to one of us, like, hey, dude, this already exists. You like use this library that exists within the core language.
Yeah. Yeah. So what Ben potentially is referring to is I built the inspect module and then he was like, go
Well,
look at the inspect
part of
module.
it.
Fair, fair. I built like a like one method in the inspect module. Um what was it like? First thing that came to mind was like realizing the magic of the layering of software. And this might be sort of a philosophical aspect, but I remember one of the first times that I got an appreciation for math, and I'm actually like comically bad at school, but I think the intuition behind a lot of the subjects in school are really fascinating. So, for instance, math is built off of one equals one. And if you stop and really ponder that, that's insane. Uh, it's led to all these incredibly complex and abstract theories that are really valuable. So likewise with software, it as you said before, I was a practitioner that wanted data to go from point A to point B fast and efficiently. And now it's like I have a greater appreciation that there were building blocks that allowed for those libraries to come in and come to fruition. It's not I don't have one equals one appreciation, but it was really cool to see, all right, if I have pandas ETL, I can go and look at the pandas source code and say, all right, it's these low level transformations. I now know how imports work. I know how the testing around pandas works so that I could see, all right, that this function is supposed to do what it's supposed to do. I have a greater appreciation for how it was built. Um, so that and there's like sort of a beauty to that and a almost like a not to go too
Mhm.
deep, but it's like a transcendence to that. Like it's I really feel like I'm standing on the shoulders of giants and I really don't matter at all.
It's not that when you're using those frameworks, it is a humbling experience when you realize like, wow, a lot of really smart people spent a lot of years
Yeah,
working on this stuff, and they built off of work that existed before that in some other language or some other framework, and it all compounds on on itself. That's standing on the shoulders of giants. That's how everything in science in general works, and
in the
particularly in
world.
applied science, which is engineering. But by knowing those references, where you're like, okay, I can go into the Panda source code and I can see how this transformation works, or like, how does it know how to manipulate this one column of data in this row construct that this thing is an abstraction over. And you start realizing like, okay, I see how that works. But then you go into the test suite because now you're thinking about that, I'm sure. Like, how do they test this?
Hmm.
Oh, I just want to see and get some ideas maybe. You look into their test suites and you're like, all right, uh, do you get that? Did you get that realization when you're doing this stuff? Because you mentioned like, hey, not test everything in Llama Index, not test everything in like core Python. Is that where you got that realization of like, yeah, somebody else is already testing this. I don't need to test this.
For sure. Yeah, it's really challenging to fully grok what is reliable and what is not. And I'm still pretty bad at it, but this project was really valuable to help me understand where to draw the lines for what I can take as truth and what I can take as stable, and then what I need to guard against.
Yeah, and it's something that, in my experience, it gets more intuitive the more you do it,
Yeah,
and you tend to, with peer feedback and with like self-reflection, you start realizing where that boundary needs to live with respect to what have you implemented and what do you need to test so that you're not encroaching on testing something that is completely irrelevant to actually test. And I've worked with teams before in the past, like customers, where you go into the team and you're like, all right, this is a test happy team, which is cool. Like they want to make reliable product here. And you look at the test and you're like, all right, 90% of everything you're testing is like core Spark. You're validating whether Spark can like join tables. You don't need to test that. There's a whole open source community that is testing that. Every PR that's filed on that repo, and every time that's released, before release, there's a whole suite of integration tests that are running to make sure that that functions correctly. That doesn't mean that the system is perfect. Whatever tool you're using, humans are writing this code and we make mistakes. We create bugs. We create regressions, because we don't have perfect test coverage. It's a myth to even have something like that. So there's always going to be something that is going to come up that's going to break your stuff that you're not actively testing. But your test should be written in a way where that becomes apparent from that test failure. And I know you've been in a lot of our stand-ups. You've seen a lot of the stuff that we talk about with like maintenance, where, hey, this test suite failed. And then you look and somebody's got a PR fixing it within 30 minutes after stand-up is done. It's because the tests are written in such a way that diagnosing that is relatively simple, because we understand that mechanism of like, okay, I can modify this one test real quick locally to debug it, or just extract this one portion of the test, run it in a local REPL and see, okay, with this version of this library that just got installed, does one equal one? Oh, no, it doesn't. Okay. We need to like pin this version or like file an issue in their repo saying like, hey, I think you just released some broken code. Uh, but if you're not testing, then you're not going to catch that. And if you're over testing, you're still going to catch that, but you're going to have an additional test that's running that is going to fail maybe once every 5 years. And when like that underlying library, if you're doing like, hey, I want to make sure that I can join these two tables in pandas and make sure that like the join is correct, and I'm testing that in MLflow. We don't have tests like that because we expect that that team that's managing pandas, they're testing that, and they do. And I've never seen something like that break. So yeah, you gain like that intuition over time, I think.
yeah, yeah. And to rapid fire some tangible takeaways, because I usually hate it when people are like, "Oh, I'm so good at this now, but I'm not going to tell you how it works." Um, so for testing specifically, some of the things that I learned was, uh, first, intuition actually is really important. it's hard to put a bunch of rules to it. That said, here are a bunch of rules. Don't test open source projects. Instead, choose your libraries that you're dependent on very carefully. Uh, the classic computer science edge cases of like, is the parameter empty? Is the parameter none? Is the parameter the right type? Those can really bog you down with complexity. And instead, using context aware testing. So, for instance, knowing where this utility fits in and knowing the constraints of what parameters are going into this utility, testing those is typically a lot more high ROI instead of testing everything under the sun that could go into this utility. Um, Integration tests are really valuable, and I think I got the highest ROI results from those. Unit tests are great to catch errors early, but typically an integration test, if it runs end to end, something is generally pretty right. And now you obviously can't test every possible combination of inputs to your integration test. So that's where sort of a very good coverage of a specific component that's a unit test, that's where it's valuable. But integration tests, I actually started with writing them and then sort of would reverse engineer some of the unit tests. And that was super valuable just to see if I was on the right track.
Mhm.
Um,
I would add
Parameter,
one. I
yeah,
would
hit
add
me.
one caveat to what you just said. Um, your intuition about that testing is a direct byproduct of the feature that you are working on.
Hmm.
So if I had given you a task, which you might get in the next couple of months, like, hey, we need this like abstract utility that does this thing, so we can refactor the code base and make it more
Good
extensible or
point.
something. At that point, you're not writing any integration tests because you can't. Like, what are you going to integrate with in order to test that full end to end? It's a utility that's used in 800 different places in the code base. So at that point, you are doing that sort of traditional, unit testing approach where you might not want to put some sort of safety guard at every point of use right before you use this function to be like, hey, verify that this is null. And if not, and if it's null, then throw an exception right here. You wouldn't put that before using the utility. You put it in the utility if you know that that's going to break the usage of the utility. And then in your unit test, you're verifying that that throws with like all the different ways in the language that you can express like falsiness, but also not throw for like a Boolean false or something. So there's some nuance to like how you would adapt like different testing strategies. But what you were building was basically integration with another library. So that naturally follows. And by the way, every flavor that I built in MLflow, I do the exact same thing. I actually write a unit, like I write a full integration test before I write any code. And that integration test will blow up because it's using APIs that don't exist. So I'll
Hmm.
write that first, and then I'll go and be like, okay, I know these APIs need to be built. I'm going to write those first of like, hey, I need to log a model. Okay, here's my skeleton for that. I need to save a model. Here's my skeleton. I need to load a PyFunk version of that model. Here's like a very simple skeleton for that.
Right.
That's, and then you work towards making that test pass.
Heard. Yeah, that makes a lot of sense. It's a good caveat. And then there are a few other things, but those I think are some core takeaways. I guess one final thing that's worth calling out is tests really inform the granularity of your functions. And so when I first built the serialization and deserialization, so you have an in-memory llama index object. Llama index is very similar, as I don't think we alluded to actually, but it's very similar to LangChain. It allows you to create vector stores, RAGs, LLMs, agents, those types of things. And when you look to take everything that is in the context of your Python code and put it onto a file so that it can be loaded in a new environment, that is a seemingly simple problem. But when I was writing that, it I basically had it too high level, and then I was like, wait, I can't test this. Then I made it too low level and was like, I'm testing stuff that's basically core Python. And then I ended up settling on this middle ground where there's basically 3 layers of steps that I think, a lot more accurately depicted what serialization and deserialization should look like in this context. So the yeah, it was really a useful learning experience about like what a function should look like how much should be in there, how discrete should it be, because it can be too discrete, but it can also be too big and then hard to test
or impossible to test
or
without
impossible.
just like sheer integration tests. And that's the trade-off with like code complexity and test complexity, or test runtime complexity, where you're like, well, in order to make this more testable, I can I can write more tests and write like a lower level implementation. But what do I gain from that? Uh, do I want like 10x the amount of code in my implementation and then 50x the number of tests? All of those take time. So you're now putting that burden on everybody who's going to contribute to that code base going forward, because they have to wait for those tests to finish or pass.
Right.
And is it really the best use of resources? And that's really the question. And what do you get out of that? Is
Yeah.
there a massive benefit to knowing like, hey, I'm testing all of these different permutations of this low level API that I built in order to do like handle serialization of all of these different types? It's like, not really. But when you do the high level, it's like, yeah, the code is way easier because, you know, but you might be exposing yourself to situations where a user or the maintainer of that tool that you're integrating with is just makes a design change, or is choosing to use this in a way that you didn't think they were going to. And now your implementation doesn't even cover that. So you basically release something that's not usable for this particular use case or will break easily.
Yeah, an example is the first feature request we got yesterday was for supporting external vector stores. And
Hmm.
this, I was well aware that this was a blind spot. I brought it up actually like a few hours to Ben before the feature was requested, and then I also had called it out like a month or two back in the design as well. And we just didn't have a note in the documentation that it wasn't supported. So the guy filed a bug saying, "Hey, this isn't working. What the hell?" Um, and then Yuki politely apologized, saying that, "Oh, we don't support that right now." And he was like, "Well, freaking leave a note in the docs. Like, what the hell? I just wasted like 3 hours." Um, and so yeah, it's there are definitely going to be blind spots, and you can't guard against them. But uh,
Well,
docs help.
that was intentional though. Like we
Yeah, so
designed
100%.
intentionally designed not to support that at first, but it'll be coming
Yeah,
probably
it's
in the next
essential.
release. Yeah.
Yeah.
So yeah, having like insight into all the like possible ways that somebody could use what you've built. How do you feel about that experience? Like, do you think you've been able to put yourself in the shoes of users a little bit more effectively, even though it's only been a week for getting feedback? But throughout the bug bash process, that's one of the reasons why we did it, is so that you could be exposed to like, what does it feel like when somebody tells me that what I built is broken?
Yeah. I have no qualms with that, other than I'm like a little bit frustrated that I didn't do it right. But I think the bug bash went well. I overall was expecting everybody to find a bunch of issues and also hit the ground running a lot faster than I thought. But it made me realize that this was a pretty context specific type of project. And if you're not aware of Llama Index and like the deep nuances of the language and the package, uh, you'll just go to the quick start. You'll try the basic stuff like, can I log a model? Can I load the model? Can I do inference on the loaded model? And yeah, and then also just like when stuff breaks, they scratch their head like any other person, even though they literally have built MLflow. Uh, it was just cool to see that like simple warnings and simple error messages are the best. Like, this isn't working. This is why. This is how you could fix it.
Hmm.
Done. That's so freaking essential. And then also having the logical path be intuitive, that is also essential. So it definitely gave me a lot of perspective onto that. And it actually has changed how I've been writing customer code the past couple months.
Yeah, that's 100% why we do those bug bashes. is what you explained. You get people in there who have no context. They're simulating a user who's seeing this for the first time, and they have to figure out, like, what do I do? So if you start a bug bash that's scheduled for an hour and a half and nobody reports anything in the first 30 minutes, that means your docs suck. There is no quick start. There is no, like, how do I even use this thing? You don't have a tutorial or an example that is the hello world for this. But if you get to a point where everybody gets through the quick start in the first 5 minutes because they just copied what's in the docs, and then once they start trying to do something different from that, like start modifying it, and you just see issue after issue after issue being reported, then your design probably sucks, which we didn't see with this implementation because it worked. And it was like, yeah, this is cool. Um, but you can be in reviews like that where professional engineers who have experience building stuff, they start trying to do things that are kind of intuitive for them, and it lets you know if the context that you're forcing upon people is so different from what they're used to. And I can tell you, like, hey,
Mm.
your APIs are non-intuitive, or they're so foreign to what everything else is with this library. Maybe this needs to be rethought or improved a little bit. Or it can be, the true happy path, which is, hey, I did the tutorial, I did the quick start, I did it like an advanced use case, everything just kind of works. And then people are diving deep into like nitpicky stuff, like, hey, this warning's really annoying, or this shows up every time that I run this. This is super distracting. And that's what I consider to be a successful bug bash, when you get to the point where people are just picking out like annoying things,
Yeah.
or he's doing something like, hey, I still have like 45 minutes to kill. I'm going to try to do like a trace on this and see, why does this one step take so long? And here's a flame graph of like why, like what I think is a problem in your code. And then you're like, sweet, that's some valuable feedback. I'm going to go fix that.
Yeah, that's basically where we got to. Everybody got the quick start up and running, other than this one weird like we think potentially llama index related bug, but not sure. And then yeah, it just became nitpicks of like there was a couple like false errors that when we tried to reproduce, it was something else. But a lot of it was like this warning is annoying. There's like 7 of them when there should be one, or
Hmm.
like this scroll bar on the UI isn't working and stuff like that. So
Yep.
yeah, I think it was successful.
So what did you think about the whole process of, like, timeline wise? When were you first given this project? What did you get
Dude,
as
all right.
context?
All right, yeah, we could get into this. So this was probably the hardest I've consistently worked, because I was working my full-time job plus doing this, um, plus trying to like live a like busy New York social life and like have friends and such. Um, and so I started this, I think, in January or something, maybe a little earlier. Do you remember?
Yeah, it was somewhere around the first of the year.
Yeah. And started doing design. And Ben had already put together an initial design doc. I learned everything in that 50-page design doc and then basically rewrote it, which was an interesting decision. I could have probably not done that, but I ended up actually grokking pretty much 100% of the concepts. And then I also did about 50 pages of uh, critical user journey examples. So basically going through the LAMP index docs. Uh, and to put it into context, when I was given this project, I didn't know what RAG is, retrieval augmented generation. Like I had heard it. I had no idea what the concept was. I didn't really know what an embedding was. I didn't know what an LLM actually was, although I used ChatGPT. I didn't know what I had built one or two design docs before. But basically every single thing that I was given was new, including like Git development, like all the things that I had discussed, and the cores of how software is made. So it was a pretty freaking painful process. Um, but one of the like intangibles that I think is absolutely invaluable that I learned is basically how to carve out time and how to create your quote unquote replacements so that you do have the ability to work on the like 10x type of stuff. And I'm still very bad at this. Like any software engineer on the team would do this like probably I don't know how much faster, but significantly faster. And so 10x isn't in terms of like value to the company, but a 10x is in terms of value to me. Like what am I learning? How am I growing? And it was really like cool to be forced into a position where all right, you can work 80-hour weeks and hate your life, or you can figure out how to delegate a lot of your existing work, and then also focus your time on what's important. And yeah, so I guess that was a very roundabout answer, but started with a bunch of design, uh, learned how to delegate a bit better, and then actually was able to carve out a bit more time. Got roped into a hell project, so my life became not fun for like 2 months. And then, yeah, started after the design generally got approved, started working on the implementation. Again, I spun my wheels a ton, didn't know how to do any of this. And after like building the wrong thing like 7 times, there was sort of an inflection point where I partnered up with a software engineer on the team and he started giving me daily feedback and then everything was quite smooth. And yeah, that was the process, I guess.
So, what preempted that pairing up?
Yeah, so Ben and I were talking about this before. He was telling me that he was like mentally breaking me down like a military like boot camp instructor, so that I was more open to feedback. And then once that inflection point hit, uh, he paired me up. Is that the angle? And I
Mhm.
did ask for the help, to be clear, or like I don't know if I asked for it, but I said I remember there was an inflection point for me where I realized dude, I spend like 6 hours going in the wrong direction for like you to give feedback once a week saying that's the wrong direction.
Yep,
And and it was like I wasn't mad at all actually. It was just like I was like, this is not going to be tenable to solve this properly. And so
correct.
I brought that up and you were like, okay, then talk to this guy.
Yeah, so I could have, and this is just like my style of this and how I've mentored people. And for like data science work years and years ago, I would do the same sort of thing. When you have somebody who they're not overly confident in their own skills, but they're good at what they have been doing, and they want to move into something different. Um, there's a way to approach that. There's a whole bunch of different teaching philosophies and styles. The one I found to be most effective for people that have a very similar personality that you and I have, which is we're generally stubborn. We like to figure things out. We don't like to ask for help too often. We would rather like brute force our way through a problem, and without positive or negative feedback and a regular cadence, whether we're asking for it or not, we can go off the rails pretty far because we're just trying to do what we think is right. And that's very much, I think, from my personal experience and working with tons of data scientists, that's kind of the way that a lot of them work. That's how I worked. Usually it's just you on your own trying to solve this problem. It's very rare that you're going to have a team where there's like an experienced person there to guide all of the people on that team and making sure they don't go off the rails too much. It's more like, hey, you know this domain, you're you're deep in the weeds, go figure it out. With software, it doesn't really like work that way, or it doesn't effectively work that way. So in order to break that habit, I just used the same technique that I had in boot camp, and I, you know, understood from military training, which is if you want somebody to really remember something and adapt to the way that other people have figured out optimal ways of doing things, you can tell people, you can explain it to them, sit down, have a couple of hours of chats like, hey, this is how you want to approach this, and here's a whole bunch of things to think about. But most people don't respond to that very well. I don't. I've never really interacted with somebody who's going to really absorb all of that. They're going to get bits and pieces. They're going to, try to figure out how to adapt their current thinking with those additional pieces of information. And that inherent bias that you have about how you know how to build a solution to something, you're not really going to change direction that much. The way that you can change somebody's outlook on something is by making them suffer a bit, making them get to a point where their process that they're doing, they themselves figure out that this isn't optimal. Or, hey, I don't know these concepts well enough, or I don't understand how this works well enough. And the terrible thing to do as somebody who's like mentoring somebody is to just dunk on the person or tell them like they don't understand, go read a book. All of that sort of negative feedback is just super toxic. And I hate hearing people do stuff like that. It's not constructive. You're not building somebody up and making them, better at what they do or what they want to do. The more the more useful thing to do is to figure out where the person is, like where that inflection point is going to be right before they're going to get frustrated and want to quit doing whatever they're doing. And everybody responds differently. So I've worked with people where that inflection point happens like days into them working on something. And I've seen people do like months working on something before you start noticing like, yeah, I'm giving you feedback that you're going the wrong direction here, and I'm trying to give you kind of hints on that, or let you know that like I'm not going to give you the answer because that doesn't do anything for you. I'm not going to do it for you. That really doesn't do anything for you except just make you feel terrible. You want to make somebody grow and get better. They need to realize that they need to rewire their brain to be open to these new ways of doing things. If this is something they really want to do. And if it's something that you detect this might not be for them, then have a candid conversation. Be like, hey, we'll help you with the project. We'll get it done for you, basically. Thanks for all the work you've done up until this point, but you'll never hear from us again, sort of thing, because this clearly isn't what you want. But for like with you could tell you. I mean, I clearly told because we talk, multiple times a week. I could start seeing like you were like, hey, could you take another look at that PR? Like, sure, yeah. And then I'd leave like one paragraph comment of like, hey, I don't think we want to go this way. And like, yeah, let's not do this. Uh, let's think about a simpler approach here. But I wasn't giving you code blocks of like, this is how to do this. I could have.
Okay,
That
I hold on. I have like 50 questions. Um, is How do you know that the breaking down is required?
because I've tried it without that, where somebody's still all pumped up and energized, and they're like, yeah, I'm doing this great job, and I'm getting this feedback right away. That can work. Uh, it's just not as efficient for me. Because what you're going to be doing is perpetuating that belief that somebody has that they know the right way to do something. So they're not going to listen in the same way in the future, or they're not going to approach their next project with as much learning as they got from that first big project. So it's all about efficiency, in my opinion.
What timeline are you optimizing for, and what goals are you trying to achieve with this breaking down?
The only goal is to make that person be better at what they're doing if they want that.
Cool. Just to be clear, I agree that it should be as open ended as what you just said. But
Yeah.
yeah,
So you
continue.
don't do something like assign a mentee. And we don't even do that to new hires at Databricks, like people in engineering. You don't assign like some massive project that somebody has no context on how any of this stuff works and be like, hey, you got 3 weeks to get this done. Design and implementation, full testing, and then release in 3 weeks. That's so far out of scope of that level of experience. You would give that to like a senior engineer or, like an L6 or something. Be like, hey, you got this. And they'll be like, another one. Okay, got it. Will do. And they'll just go off and build it because they've done it 100 times before. So it's it's so common to them. They know, they've learned all of those processes. The hard thing that it is for somebody coming new into that environment from the outside is that they didn't see those people that they're now kind of idolizing as like, whoa, this person's so good at what they do, and they're so like they're so smart and they understand all these concepts. You didn't know them 7 years ago when they were in your shoes and what they dealt with on that first project. They might have had like a good mentor who was like really helping them along and making sure that they grokked these concepts that first time, or they might have had a terrible boss who was just like, sink or swim, man, figure it out. And they had to learn, they had to feel all of that stuff internally and break themselves down and feel despair and then, get it working eventually with, a massive, probably stress and health hit to themselves, for being under that kind of pressure. Yeah, I don't, uh, you can do that. Or you can handhold somebody for a year and make sure that you as a mentor are just there for them at any given minute, and you're not going to learn that much at that pace.
Okay, so there's a spectrum of handholding forever to get this done in a week. Uh, Handholding forever is the easiest path, learn the least amount. Get this done in a week is the hardest, learn the most amount, probably. And the sweet spot is sort of in the middle. Uh,
So this is a seesaw relationship, though. So when you're talking about the easiest path versus the hardest path, that's speaking from your perspective. But the hand holding is
Good
the
point.
most amount of work and the most amount of like just time sunk into something for a mentor, because they're helping this person, 4 times a day, answering all their questions about every little like minute detail. Like you're writing a function, you're like, I don't know if this is right. I'm going to code snippet this and send it to my mentor. Is this how you would do this? And they're like, yeah, it looks good. Write a test for it. What does the test look like? You know, that constant feedback type thing. I've never really worked anywhere where somebody's willing to do something like that, because if you're a mentor, you're usually fairly senior and you've got a bunch of stuff to do during your workday that is probably more important than hand holding somebody. S- But that's the easiest thing for the person learning, because they're getting answers like all the time. They're getting unblocked like continuously. And, you know, it'll be a fun experience for them. You'll learn, but you're not really learning. You're not figuring out how to figure it out yourself.
Right.
But
Okay,
then
so
there's the opposite spectrum is ultra hard mode for the person who's learning this concept. And then the person who's like the mentor, they do nothing other than just, review bomb after like several weeks of abomination being written. And they just drop a like, hey, this is way off base. This sucks, or you suck. Why'd you even do this? I don't think that's productive.
right. What is the timeline that you are optimizing for this knowledge? Is it like lifetime or is it the next 2 years or like
For
when
the
should the
person
fruits of the
learning,
labor, yeah, when should the fruits of the labor start paying off?
I think that's dependent on the person, uh, and what their own personal motivation is, or what their personality is and stuff. But somebody like really wants to get into learning something. This isn't just about software, but just learning something, and they're clearly willing to put in the time and energy to it. Once they have really learned their own limitations, which sort of reprograms your subconscious to a certain degree, you now really know what you don't know. So you've gone past that trough of disillusionment, and you're now like coming up to like, okay, I know that I'm deficient in all of these areas, and I know what to work on. But you start knowing really what you should be working on, not just, I'm gonna get good at everything. I'm gonna be the world's best at whatever this is. Anybody who's really good at something, they don't think like that. You're like, I've spent some time learning how to learn this thing. So when I need to learn the next thing that's adjacent to this, I know the most efficient way to go through that because I did this super painful thing, or my mentor put me through this super painful exercise to teach me some core concepts about how I need to approach this. And that's what I was trying to do, which is, okay, Michael just dropped 2,500 lines of code in this PR. And I did tell him to split this up, but let's see if he gets the concept of like smaller commits with review, and then not doing stuff like re-implementing core language functionality, and you know really grokking serialization. Like, what is a simple way to do this versus this super complex, arguably correct way to do it. A couple of the ones that you pushed out there at first, I was like, that's definitely, that would work, but nobody wants to maintain that, because it's re-implementing something that already exists, or there's like way easier way to do this, and that's what we try to push for, is like simplicity. So, but you would not have learned that if I just given you the code snippet, like, hey man, this is how you serialize JSON, or this is how you deserialize back into an object.
Agreed.
But then there's a certain point where when you hit that inflection point, you absolutely have to, if you're using this sort of process for mentoring, you have to get that person, once they've been broken effectively. That's a bad term, but like once they're ready to like really get something out there, and start getting really good at this, at whatever they're doing, you have to give them the means of working with an expert who's going to have the time to like provide that consistent feedback in a short period of time, um, that kind of works for them. Because what you do at that point is you set a deadline. And if you're just going through and you're like, okay, this person, like, they broke a bit, and now I'm just going to set them a deadline, and put even more pressure on them now that they've learned a couple of these concepts from this feedback, and they've done self-reflection of like, oh, this is how I need to solve these problems, and I've learned all this cool stuff. That deadline is just going to put pressure on that person if you don't give them any resources. So that way, as a mentor, if you have time, you can be that resource. Um, Unfortunately, I did not have that time, but we had somebody on the team who finished all their quarterly work early, and I was like, this is a match made in heaven. Just gonna be like, hey, sat down, talked with him for a little bit, and was like, here's what you should be going for. Like, let's make sure that this needs to deliver by this date. Here's our deadline, but um, make sure this guy like really understands all this stuff and sees like how to approach these problems in a different way. And he got super excited. He was like, yeah, I'm really excited to work with him, and this is going to be fun. And yeah,
Yeah, it
and it
did.
released.
It did release. And also,
But more
yeah,
importantly, way more important than the feature, you learned all that shit. Like, you're never going to forget some of the stuff that you learned because you had to go through that process of being like, okay, I went off the rails this many ways. And part of that is not just the technical competency of understanding all of these concepts. It's also soft skills too. It's understanding like, okay, how do I short circuit my propensity to go off the rails by getting a peer feedback early, and like talk through a design with somebody, or talk through like that implementation detail, um, and then respond to comments to that and like fix that or adjust it to this other way of going. Because eventually, 6 months from now, a year from now, you'll be working on a feature, and you're going to get that peer feedback on that PR. Your PR will hopefully be like less than 500 lines of code, and then somebody can just look at it, and your next step after where you are right now, which right now, if the person that you were working with wrote a comment on a PR requesting you to change something or just asked a question, your propensity right now would be just do what he asks. right? Like he knows more than I do. I'm just going to do that.
100%.
Right. But a year from now, if you can prove that that comment is irrelevant to what you're doing, if you look at the PRs that we do with one another, it's not just one person saying, "Hey, fix this," and you just go and fix it. Sometimes it is that because you just overlooked something or didn't think about it. But a lot of times there's discussions that happen back and forth.
Right.
Like, "Hey, are we sure we want to do this?" Translate, "Hey, I think this is not the right way to do this. Please fix this. Here's a code snippet that I think you should use instead." And then the next comment is, "I don't agree. Here's why. And here's example of like a test that I wrote that validates this." And then the other person's like, "You're totally right. Yeah, yeah, keep your first implementation. Like that's way better. Or change it to this instead." And then the final comment is, "Sweet, thanks. Awesome. This is so
Yeah.
much better." So yeah,
Yeah.
it's getting that back and forth. And the only thing that builds that is just time on keyboard.
Yeah. Yeah. I have actually had a few really good back and forths in the Llama Index implementation. Um, but the key thing was being comfortable enough with the material to have a discussion.
Yep.
And a lot of times it's like at least some concepts go above my head. So for those, I'm just like, all right, I don't really have the time to learn every nuance of what you know so that I can see if you're right, especially if you're a trusted expert in that area. But yeah, there were plenty of times when I was I didn't know more necessarily, but I had done my homework and thought that it was wrong and brought up my point. Sometimes it got overruled, sometimes it didn't. So yeah, definitely that back and forth was valuable.
Yeah, you start to self calibrate when working in a team like that with the feedback of, hey, some people's knee jerk reaction to any comment is to argue uh, or just say, like, "Hey, I have this other viewpoint that I think is more valid." And then that other person's like, "No, here's the evidence. Like, don't do that." You'll start to self calibrate to be like, to be able to read a comment and realize instantly, like, "Yep, they're totally right. I missed that." Or,
Yeah.
"No, they're totally wrong. I need to actually fight this." Um, and you're kind of spoiled in our team where the number of comments is, it's usually 90% valid, uh, 10% maybe that are up for debate. But I've definitely worked with other teams before where you go through a PR process and it's like the inverse of that, where it's like it just becomes this weird flame war, and you're like, "Is there an adult in the room here? Like, what's going on? Who's actually the deciding factor on like merging this thing?"
Hmm. Interesting. Yeah. Yeah. Just the dust is sort of settling, so I don't have a bunch of like really insightful zingers, but not that I ever do. But it was a really cool process because like the breaking down aspect probably was necessary, even though it kind of sucked. Um, it was also kind of cool though. Like I'm a bit sadistic when it comes to those types of things. Like I like a real challenge. Um, And then one thing that was really eye opening when I partnered up with Yuki is getting that daily feedback was like a breath of fresh air. Like I really cherished every sentence that came back from him. Not only is he like very good and smart, but um, now like a direction that he gave meant a lot more because I had all of these theories that had already populated in my mind and I could just axe like two-thirds of them. And then the rest of the third of the theories that were still active, I could quickly implement because I had already had to go through the pain of thinking that I needed to create all the possible solutions, test out each one, learn what was the best, and do that all on my own. Once he could like narrow the solution space down to this set, I was like, sweet, I can bang out 5 iterations, pick the best one, PR it. So
Mhm.
yeah, I definitely have to think on it more, but the breaking down is a cool concept.
Yeah, it just makes you more open to get that feedback. Really,
Yeah.
it's preparing you for the process of peer review. Um, and you learn like a bunch of core things that are very useful, like tools in your tool belt while working on stuff like this, of understanding. Like you mentioned a bunch of like technical things about the Python language, like, oh, I didn't know about parameterization of unit tests using the PyTest framework. Cool to know. Like definitely super valuable. Um, it won't be something that it'll be knowledge like a year from now that you'll just have intuitive access to. You'll know when to do that, when not to do that. Um, and the more that you write and the more feedback that you get about like, yeah, you could parameterize this test, but there's a certain point at which like you have logic control flow within your unit test that acts on the parameterized values in this super convoluted way. Like if this condition
Right.
and this condition and this, it's like just split the tests up. Like we don't need to be fancy and create like parameterization for stuff like that. Just split it up.
Yeah.
Because there is something to be said about like simplicity and like readability, and really with with using those tools, uh, if you abuse them, you could theoretically, write an integration suite where it's just one test with this monster freaking parameterization setup that you have, where you're, you know, not testing certain things if this condition is this way. And when you look at something like that like an abomination test like that, and then if you're just writing it and somebody else is maintaining it, you won't even bat an eye. You'd be like, yeah, I wrote something cool and complex. However, if you're the one getting tagged for, hey, this test failed, we need to figure out how to fix it, and you open that up and you see somebody else did that, your first thing that's going to pop in your head is like, who did this? Like, why is this so complicated? And in order to fix this, I have to rewrite the test, like the entire test from scratch. And I'm not going to be using this complex logic chaining here. I'll just create 18 tests, and like 4 of them might be parameterized. So yeah,
Right.
you get experience by just doing it.
Yeah. Exactly. Okay, cool. I think I have a general summary in my head and I'm ready to summarize. But any other things you wanted to talk about before we close?
I think for next time, we'll do some additional, once it bakes a little bit more in your brain,
Yeah.
because I know you're going to self-reflect over a lot of the process.
I'm going to use all this shit. Like, I'm going to go and, like, break down my colleagues until they're ready to cry and then say, this is how you write a pie test. Um, no, I think I need to put some of it into action because there's some things that I'm very bad at taking someone else's word as fact. I need to understand it and make it my own concept.
Mhm.
Even if it's word for word what they said, I need to arrive at that conclusion. And so I need to, I think, use some of these concepts in action before I can actually have good thoughts about them and good intuition about them.
Mhm.
Um, but okay, cool. So the purpose of this podcast, at least what we set up from the beginning and hopefully achieved, was to demonstrate what it looks like to have a very large learning opportunity and then reflect on that. We talked about the process of, all right, initially throwing someone in the deep end, watching them flounder around until they're like, all right, I need help. But throughout that process, they learned how to tread water. They sort of learned what it feels like to have water go up their nose, maybe not breathe for a few minutes, well, seconds, I don't know about minutes. And through this process, they become a lot more open to learning. And then once you actually throw them the life raft, then they are typically a lot more able to swim on their own and they need less guidance. And also, the lifeguard, in this case, the mentor, doesn't have to do that much work. You're just like generally checking in. All right, have they drowned yet? No. Have they drowned yet? No. No. As soon as they're drowning, go help them. Um, so I still want to think about that concept to see if the drowning is necessary, but I think it is. And I think I personally benefited a lot from it, even though drowning isn't fun. And yeah, I think all the other tangible tips are not really relevant, but that's sort of like the core underlying principle.
Definitely.
So yeah, That's about it. Anything else?
No, I would just encourage people who are interested in going through that process of like approaching mentorship or menteeship with thinking about, you know, intentionally doing stuff like that. And you don't tell the person beforehand. It doesn't work if you do that.
That was
You're
gonna
like,
be the
hey,
first thing I tried. I was gonna tell the person. Why can't you
like,
tell them?
it won't work. If
Why?
I was like, hey, I'm going to screw with you for, you know, a month or 2 months, and I'm going to like intentionally try to break you, most people are like, why are you such an a-hole? I don't want to do this. Nobody
No.
signs up for that. What do they do in the military when, well, I can tell you what they do in the military.
Yeah, I have no idea.
When you've seen the commercials for like recruitment into the military, they show a bunch of people storming up a beach, carrying like assault rifles. They're like,
Oh
yeah,
yeah.
go Marines, or like show a bunch of like crazy cool warships, doing donuts in the ocean and firing missiles and guns and stuff,
That's what the
appealing to a
wars are,
base.
right?
I mean, if you're appealing to like, this is the cool part, you're going to be in
Hmm.
a fraternity of like soldiers and sailors, and you're going to do all this stuff and tour the world and get to see all this cool stuff. In reality, is not that at all. It's a lot of hard work, a lot of boring time spent just waiting, a lot of intense instruction, just unpleasant living experience in general. So if you tell everybody, if those commercials were accurate of like, here's what it's really like in the military, nobody's gonna sign up. They're gonna be like, this sucks. Like, why would I sign up to do that? This is terrible. So what you do is you trick them basically into this ideal of like, hey, you're going to do this thing. That you're telling them what some of the things are of the end goal. And it's the same with mentorship. You're teasing somebody with appealing to what they want to get out of something, and they will get that if they follow the process. But your first day of boot camp, you get off the bus at Recruit Training Center, and you have these people just screaming in your face and telling you like how stupid you are, and like, why can't you follow simple instructions? Do you know how to stand up straight? Why do your clothes look like that? Like, why does your hair look like that? They're just messing with you. And that starts that breaking down process of, at first you're just afraid of like, what the heck is going on? And then they keep you up for 36 hours straight and just waiting and like standing in a line while they're like processing people in. They're doing all of this intentionally. It's not the most efficient way of doing the things that they're doing, but it's the most efficient way to break somebody down so that they start listening, like really listening. So you have to get to that psychological break point of like, I don't know what I just got myself into. I don't want to be here. And then within 2 weeks, you're just like, you're following orders, you're doing what you're told, you're getting things done in the way that they need to get done, which is building up that knowledge base and that experience so that it can be built on later. So that's that whole like indoctrination process of, hey, there's an efficient way of doing this that's not focused on what you're learning. It's focused on the learner themselves.
Heard. I feel like I have a bunch of caveats that I want to test out. So we'll report
But it
back.
doesn't work for everybody. That's like the
Exactly.
big
Yeah.
thing. Like, not everybody responds to that, but that process is also a way of weeding people out. So if you came to me like 6 weeks into the project and you're like, I'm not getting any feedback, I'm not gonna like, I don't want to do this anymore. I'd be like, all right, cool, no hard feelings. Like no harm, no foul. This isn't for everybody.
Mm.
Same
All
thing
right.
happens in boot camp too. Like there's a
Yeah.
washout process. Like you want to identify people who don't want to be there because they can go and do something else, or you know, it's no judgment on them. It's just like, hey, this isn't for you. It's fine.
But like, is there not another way to achieve this openness and like quick growth mindset without the breaking down process, or is that the only way?
Of course, there's other ways to do it,
But
but
this is
is
the
it the
best way?
most? Uh, it's one that's worked for me many, many times, and it's one that worked on me. I wasn't
Mm,
exactly the most receptive person coming out of high school to be like, yeah, I'm ready to be a warrior. I wasn't there for that. I was there for education and experience. But by the time I got done with, all of my schooling and stuff, I was able to do things that there's no way I would have been able to do that if I hadn't started with that day one walk off the bus to be able to like know my own limitations. Like,
mm,
oh, I can actually do this because I did that. Or, hey, they taught me this concept through a subconscious means that I'm not like afraid of failing with trying with something because I was taught not through like verbally. They don't sit you down and be like, we're going to do this for you and you're going to become this person or you're going to learn how to do these things. There's none of that. It's all experience based and you never forget it.
all right, I believe it. Cool. Well, we're over time. Um, yeah. Until next time, it's been Michael Burke and my co host,
Ben Wilson,
and have a good day, everyone.
we'll catch you next time.